Hey everyone, it's nice to see everybody join this presentation. I'm very glad to be hosting you here and talking about why you should write dApps in Go. My name is Leon and I'm a developer relations engineer at gno.land. I've been in Web3 for about 4 years and I've been writing dApps in Go for the last bit and I want to talk to you about it. So essentially, this is going to be the agenda. It's going to be kind of short, and this is a bit of a joke, obviously, but we're going to talk about what is Go, how we can write an app in Go, then something in between, and then we're going to have a complete app. And essentially, first of all, what we need to get started with is what is Go and why should we care about Go as a language. Essentially, Go is a general-purpose compiled language, and it is been around since around 2009. It was open source in 2009, but Google built it in around 2007. It's kind of like a successor to C. Some people call it the C of the 21st century, and it's statically typed. So it's a hard typed language. And essentially, the question is why, again, should we care about Go? Go is used to build backend services. It's used to build protocols. For example, some of you may know about Geth. It's Go Ethereum. It's an Ethereum client that's built in Go. It has a great standard library and also an amazing set of tools to work with. And but most importantly, I think one of the biggest reasons about why we should care about Go itself is that it's super easy to learn, right? It has a very straightforward, very easy learning curve, and it has lots of battle-tested libraries as well as resources by a large dev community, right? It's been around for 16, 17 years, right? So it's so easy to learn, actually, that I'll actually show you and I'll let you learn a little bit about Go right now. So we're going to do a little bit of live coding, where I'll just kind of give you the really, really big basics on what Go is and how it works. So here I created a very simple folder. It doesn't have anything special except this post.go file. Let's actually remove that. Let's do this and do touch main.go. And then we're going to define a package called main, in which we'll have func main. And I'm assuming most of you guys understand this, so it's a relatively simple syntax. It's quite familiar, right? Anybody who's written any sort of general-purpose language will understand this. And then we'll do fmt.print line, and we'll say, hello, Belgrade, right? So I guess most of you guys know what this is, and here we basically say we're using this FMT package, which is format. It's used for formatting stuff, and we're going to print a line saying hello world. And again, Go is compiled, so we have this Go binary. If we do Go version, it's going to plop out that it exists, and it's 1.24. And what we can do is we can do Go build, and we give it the current folder, and then we get a executable file. And we can do this and run it. So that's one way of doing it, obviously, with a binary. But another way of doing it is doing go run main.go, which is just like basically a command that integrates two things. So it builds and runs your library. And there we go. We get hello Belgrade. OK, cool. So I defined something here at the top called the package, right? And package is basically a organizational unit of code for Go. So let's create another package. Let's try to do something else. So let's do make dir social. Let's call it social. And in this social folder, we're going to make another file. Let's call it social.go. And then up top here, we're going to do go mod init. And this is going to be this is a way of tracking dependencies, essentially, in Go. And you'll see why we did this go mod init soon. But in this new package that we're doing, so imagine that this is something that you'll be able to share around and basically reuse as a piece of code, modular piece of code. So package social. OK, let's do this. And now let's imagine that we want to make a very simple social media application. OK, so let's talk a little bit about how you would do it in Go, and then what are some of the things that you would need to do and define. So let's just say we have this very basic struct called post, and then we'll be able to save these posts and also view them and then create new ones, etc. So for example, the way we would start with this is we would do type. We can define a new type called post, and it's type struct, right? So it contains some things inside of it, and it has like a text, right? Then it has like an author. Oops, that's an automatic import. Never mind. So an author, let's make it a string, and also has like a created at, like when it was created, right? And this is time.time. So this is a built-in one of the standard library packages for Go. So this is quite a familiar thing if you know any Go. Okay. And then let's actually export these. So the way it works in Go is when you have a capital letter at a definition of a variable or a function, essentially what happens is that thing that has a capital letter, it's named with a capital letter, is exported outside of the package. It's visible outside of the package. It's public, right? So we have this post, and it has some data inside, okay? And then let's say we can do like func create post or new post. Let's call it new post. No, let's call it create post. Create post. And let's make it return a pointer to a post. Okay, so it's just returning a piece of data that's going to be packed in with these, right? So let's say that it takes some text and it takes an author. Okay, and let's just return the pointer to a new post. Okay, so we're creating a new post in memory, and we're going to say, okay, the text of the post is the text that we pass in. Oops, all right. A bit clumsy there. So text equals text, and then author, let's say author, so whatever is passed in, and then time, or created at, is going to be time.now. So what this does is basically gets the execution environment, right, and it checks what the time is at the point of calling this function, and then it just writes it down, right? So this is quite simple syntax. Okay, so let's do that. Then let's go back to this main file, and let's say that we want to actually like use this package in some way. So what we can do is we can do social dot, and then we can do create post. And you see it's going to automatically import this social package, which we have, right here, right? And the logic is that by doing this packaging, right, you can organize code better, right? And you can have it imported in one place and exported in another place, etc. So this is kind of the way we do things in Go. Okay, and let's say what we can do in Go as well is we can say var, so we're defining a variable, post, and we can say social.post. So this is getting the type, right, from the other package, from here. And then let's actually make it a pointer, because that's what we did over there. And then what we can do is we can do post equals post social.create post, and then give it my first post, right? And then we also need to give it a author. So let's say Leon, for example. And then what we can do is we can do fmt.println post dot, for example, text, right? So we're making some memory, and then we're just printing it out to the standard output. And also, the editor here is saying like, hey, you can actually do something else here. You don't have to do that. You can just infer the type, because Go knows that when you call this function, it knows its return type, so it's hard typed, statically typed, and it knows that this here variable is actually of type post, right, or pointer to a post. So let's try to run this. Go run main Go, and there we go. Like we actually got something, right? We can also do something else, like for example, showing that we can actually do the address of this, and it's going to print out an address for everybody who knows what pointers are, right? So this is some basic Go. Okay, let's add one more thing here, and that's going to be like a way to view posts. Okay, so let's call it view posts, or view posts. And then here, for example, we'll be able to pass in a list of posts, let's say, post, and then it's going to return like a string or something, right? So like we want to actually be able to get some slice that has data, and then just print it out to the user, okay? So let's say, okay, let's have some out, which is going to be like posts, and then let's add some new lines here. And then let's actually go through this posts. So p in range posts. And we also need an I. So we're going to iterate through this slice, or array, as it's called in Go, a slice. And what we can do here, we can just do out plus equals. So we're concatenating strings. Let's say string. Let's actually do FMT. So FMT allows you to do string formatting. So printf is a function that you can use. And we can say, OK. So we're going to have the post number. So post number something, right? And then let's do a new line. And then let's do text. Oops, text. And it's going to be a string, right? And then let's say here I, and then let's do p dot text. And then let's add the rest. So this is going to be the author. And then this is the author. And then this is the created, or let's say date. Yeah, that's easier. P dot author, and then P dot created at. But this is a time.time, so what we need to do is we need to actually do a format on it. And let's say 0201, so 2nd of January 2006. This is a standard way of doing it in Go. OK, and then we do return out, right? So we're passing in some slice, a list of posts, right? And then we're actually like just printing them out to the user. So this is a way of displaying what's happening in our application, right? So let's try to do this. So let's actually do a couple of these. Let's do one post 1 0 1 2. Let's say this is my second post. This is my first post by Alice, let's say. And then what you can do is you can say var, or let's say posts, column equals, and this is going to be a slice. So we're making a slice of pointers to posts. So this is going to be social.post. And we can say post 1, like this, post 1, post 0, post 1, post 2. OK. And then what we can do is we can say, OK, so from the social package, we can do social.viewPosts, and we can pass it the posts. And then we do fmt.println, like this. And then let's actually run this and see what happens. And there we go. We actually get these posts, right? But the issue is, well, what's the issue? The issue is that everything that's happening here in this application, right, it's just ephemeral. Like, it's not saved anywhere. It's just in memory. When I run it, it happens, and it's gone, right? But OK, so we've kind of made something, right? We've made a very small social media application. Not really, right? But it's kind of something. It's kind of looking like something. So imagine that like we now want to make actually like make a business from this, right? We want to do an actual social media application. The thing is that there's actually a bunch of steps in between this and actually launching an application, a full application. For example, think about, OK, well, first of all, we don't have a place to store our data, right? Where do we store our data? That means we need a database. OK, so let's make a database. Let's make a model for a database, right? Let's run the database somewhere. Let's push it to some server, right, or some cloud. Let's put it somewhere. So that's step one. Step two is then, OK, well, then we need to define an API, right? OK, well, what's the API going to look like? Blah, 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 right? You get the point. It's kind of complicated to do these things, even though, of course, there's shortcuts, and you can use pre-built stuff and everything. But overall, when you look at the tech underneath, it's relatively complex. You have to do a bunch of stuff, a bunch of different stuff, and you have to diverge from writing this simple language called Go. On top of this, for example, at one point you'll want to write front end, right? And then you gotta usually do that in JavaScript or TypeScript. So it's not the most fun experience. But OK, so I kind of showed you just a little bit about Go and how it works. You kind of got the gist of it. So let me now go back to the presentation. And yeah, well, let's say, OK, so what if we had automatic persistence? What if we had language-based app features? So instead of having to make this thing called an API, and instead of having to run a server and exposing endpoints and doing this and doing that, what if you can just have exported functions be the API, right? Or the methods, right, be the API. OK, what if you can just have top-level variables, so defining a variable at the top, which is going to represent a database for you, or like the state of the application, right? So you don't have to care about creating all these separate systems that are going to have to interconnect them, and then you have something like an app. It's a bunch of different things, right? In this case, it's just one. It also has built-in security, and obviously, like we're talking about blockchains here, so built-in security, decentralization, they come together. You know, they come as a bonus. And then also, well, this is kind of a really nice thing. You can have an easy-to-make front end, and then one CLI command to publish the app. Right. So just imagine how much more simple that is compared to all of the things that we talked about previously, having to deploy all of these services, having to make sure that everything is secure, having to make sure that the design is good, et cetera, and then also having to pay for the hosting for all of these services, et cetera, right? So, well, basically, all of this, well, we kind of have it with something called GNO. Essentially, this is GNO. And you kind of see that it kind of looks like what we just wrote in Go, or basically identical, right? So here on the left, we have a package called Alice. Let's say Alice made this package. And on the top, she defined a variable called x. And it's an int. And then she defined a getter and a setter, right? So nothing special, very, very simple. And then on the right here, we have Bob, who's saying, OK, well, Alice made an application, and she exposed some functions. So she exposed the getter and the setter. And that means that I can access it, because we said that exported functions, by the virtue of the language, right, are APIs. So we import the package called Alice, and then we can just do, hey, alice.get, which is that, and then we do alice.set, and then we set it, right? So that's kind of the logic. OK, that's interesting. A little bit more about GNO. So it's modeled after Go 1.18, so it's a little bit of an older version of Go, not like super old or anything, but it's not the most up-to-date one. It's interpreted instead of compiled, and there's a reason for this. And it does not support all of the features that Go has, for example, generics and Go routines. For those of you who know, Go routines are a way of doing things concurrently, which doesn't really make too much sense at this point in blockchain systems. And all apps, everything that's deployed to this blockchain network called gno.land is ID'd by something called a package path. So it's kind of like the place where your application lives. OK? So this is kind of like a very, very simplistic way of saying what a GNO package path is. There's a namespace. So for example, my name, or like imagine GitHub, right? You have a namespace, and then you have repos under it, and then you have the app, right? The way you identify the specific app within your namespace. And then on the left there's some other stuff, but it doesn't matter really too much right now. And basically, why I'm telling you about these package paths is that OK, so who knows here about how you deploy stuff on Ethereum? OK, good, great, OK, nice. Yeah, so basically when you deploy, you get a random address where your application lives, right? So it's randomly generated. You can kind of play around with it in some weird methods, but essentially, for all intents and purposes, when you deploy something to Ethereum, you get a random address where your application lives. In this case, it's not like that. You can define a specific name, essentially, for your application, a specific path for your application, kind of like a file system, right? Kind of like an organizational system. And why this is important, it's because we have this thing called GNOIB, and this is like a very special tool that we built. And it's essentially the universal front end for gno.land, for the blockchain, for any app on the gno.land blockchain. Anybody can run it because it's open source, and it's super easy to run. And it uses a pre-built query that's built in, it's built in into the app. And it basically says, hey, like when you browse for this app, you do a specific query, and then you get the state of the app. This is why you don't actually need to write any JavaScript or TypeScript. You can just write GNO code, and you'll see that in just a sec. So this is a very basic diagram of like how this essentially works. So I'm the user over there. I'm looking for this Leon/app application. And I ask GNOIB, hey, like, can you fetch me this application via a search bar, essentially. I'll show it to you later. And then GNOIB says, hey, can you query app.render? And then the network says, yeah, sure, here's the state. And then GNOIB, because it's the front end, displays it to the user. That's a very basic way of doing it. So like this talk is named Writing dApps in Go, but like where's this dApp? I haven't seen it yet. So this dApp is right here, actually. We kind of wrote it already. What we're going to do is we're going to delete this. We're going to delete this. And then we're going to do cd social. gno mod init. So previously we did go mod init. We're doing gno mod init. So this is the GNO version. Let's call it Leon mini social. So this is the thing on the left that I mentioned, but it's not really important at this point. And we get this GNO mod file. And then what we also can do is let's rename this. Where is the rename? Rename, there we go. And let's just do GNO. OK, awesome. So we have GNO code. And this kind of works already. But what we're going to do is we're going to change this to render, which is what GNO web is actually expecting. We're going to do underscore string here. We just don't need this variable, but the signature needs to be like that. And then another thing that we mentioned previously is that these top-level variables, right, they're specifically used for being able to store state of your application. So what we're going to do here at the top is we're going to say var posts, and it's going to be a slice of posts, just like previously, right? Of posts, yeah. And then one more thing that we need to do is we don't have FMT, we have UFMT here, which is a replacement. And here it's automatically imported because the editor actually knows how all this works. And then finally, one thing that we're going to do here is, because essentially when you call this, it kind of returns a pointer to you, but where does that pointer go? It doesn't go anywhere, right? Like the memory is just like poof, it just goes away, right? So what we're going to do here is we're going to do P, which is going to be the post, and we're actually going to do posts equals append. This is the way you actually save something in a slice in Go, and we just append it here. So instead of like returning the pointer, what we're going to do is we're actually just going to save it to this slice that we defined up top. Okay? So, and look, this is essentially the app. That's it. There's nothing else. Like, we don't have to do anything else. And how we're going to run this is I'm going to use a tool called gno.dev, which is really, really cool. For everybody who knows Ethereum, you kind of have these local environments where you can create a local blockchain, you can publish to it, you can play around with the mock stuff. In this case, we have a tool called gno.dev, again, which is a very, very cool tool because essentially, it's not an all-in-one tool, it's a development solution stack. That's a better way of naming it. It contains a couple of things. So here you see, it contains GNO web, which we just talked about, and it contains the node, right, the local blockchain node. And essentially what it does, it's also really, really cool. It like auto-deploys stuff for you. So you can click on this listener here for GNO web, and you can actually open it. And this is our app. Like it browsed for our app, and it found this at this location on the local blockchain. Right? So let's kind of make this a little bit nicer. The really cool thing about this is that gno.dev also has a hot reload feature. So what you can do here is you can do like hashtag. And by the way, you might have noticed that this is markdown. So what you're doing is you write markdown, and then it just kind of pops up, right? So let's say, for example, here, let's say if posts.len equals 0. Out plus equals no posts yet, and we're sad about it, right? Okay, and then return out. It's going to reload, right? And then there you go, right? So we're literally writing a front end in GNO. Okay, so we don't really need to write anything else except this. And it's really, really cool because when you look at it compared to a traditional application, you would have to write all of these services and deploy everything and make sure everything is tightly, working tightly together and it's secure and everything. With this, you just write GNO code, poof, publish it, and it's right there. It works, and it's great. So yeah. Okay. What else? What else should we add? So let's add something else. Let's do like func. This is a cool thing in Go. You can define methods on top of structs. So we can say like let's make a string. Function or method for our post, right? So instead of having to do this, right, we can just take this and we can do p dot string, right? Just making it a little nicer. Out p dot string, and then before that, what we're going to do is we're going to do out plus equals post number whatever, right? Plus string strconv dot okay of I, and then let's do some new lines right here, just because that's the way Markdown works. And then we just slap this on, and then here we can post this. We can do return, okay, and then let's just remove this part here. So this is basically rendering the post, right? And we kind of modularize it this way. And then let's see what's happening here. Unknown, did I make, no, I just need to import it. Okay, I don't know why it's complaining. Looks good. Okay, and now let's actually do something really cool. Like, let's actually publish something, okay? So let me call, so here on GNOWeb, this is also another really cool thing. Apart from GNOWeb itself, we have a tool called GNOKey, which is kind of like a, it's not kind of, it is the wallet that we use in GNOW. And here we can like post in, for example, the text, my first post, and then call it Leon. And let me actually just post this. So it gives you a pre-built command that you can just slap into your terminal and run it. And we get an OK. And then we go back to the app and we see, hey, there's something here. Right? That's pretty cool. Let's make it a little nicer. And also another really, really cool thing is that even though GNOdev like does a hot reload, it actually saves the state of the blockchain before it does it. So it's like super, super nice to actually work with because you can do this. So let me do another new line here, and here, and here. Okay, and then let's do like, for example, a triple dash, which is going to give us like a, not that, this. It's going to give us like a, I don't know how you call it, like a bar. And let's do like H3 here, for example. Okay, and then it looks a little nicer, right? And then let's do another one. Let's do another post. Let me change this here. Let's do my my second post. Yep, and there we go. It's right there. Okay, so this is kind of like, the thing is, this is actually like a full social media application. Not really full, but like this is the basic concept. Like it's a POC, and anybody can copy it. And this is what, like, it's not even like 50 lines of code. It's like super nice to do this. And there's a command that you can do with GNOKey, which would be make tx add package, add pkg, which is basically just publish the package to a blockchain, right? So that's what I meant when I said this is the only one command that you need to publish an actual application instead of having to spin up all of these services. I want to do one more thing here. And that is, you see here, we're kind of passing in the author, but that's not really realistic, especially on blockchains. You know, you would want to get whoever made the transaction, right? So let's do that. Let's just change this. And here we actually have something. We have a package called std, which is a super important package for GNOW. And then we can do previous realm dot address, and we don't need to convert it to string. Maybe we do. String, OK. All right, that's perfect. So these are transactions failing because we changed the number of arguments in the function. Let's go back here. Okay, so there's no post now. And then let's say create post, hello. And then we can copy this, paste it here, run it. And there we go. Like the author is me. So this is the GNOW address that I use. And yeah, that's kind of the gist, you know. We just made a basically a very basic application that anybody can use and publish, and it's like 50 lines of code. We didn't need to write any other language or anything. We just published this, and people can actually use it as a decentralized application for like a Twitter, right? So I think that's really, really cool. But I'll let you guys be the judge of that. What do you think about this? You like this? I mean, does it look cool? Does it look simple? Yeah? Okay, that's cool. Very nice. There's also a bunch of other things I could show you, of course, but let's not do that right now. What I want to do is finish this presentation here. So let's just jump back in here, and let's just talk a little bit about what tooling we have and the ecosystem that we have currently. So we have GNOKey, which I just showed you. It's the wallet, the CLI wallet that we use. We also have a web extension wallet, of course, that's called Adina, and we'll talk about that in a little bit. We have GNODev, which I showed you previously as well. It's used to basically run a local blockchain node. It does a bunch of really cool things. One thing that I didn't mention is that, you know, like every transaction needs some gas, right? So the idea is that how did I get gas on this local network for my specific address? Well, GNOdev is really, really smart and actually gets the keybase that you use in your GNOkey wallet, and it pre-mines things to it. So it's super practical. And it has, obviously, a directory watcher with automatic code reloading. We have something called the TX indexer. This is a blockchain indexer which has a GraphQL API, and it's super, super fast and practical. We actually did a 10x on its speed some time ago. It's super nice. We have the GNO Playground. If you want to test out GNO, just play around with it, do some stuff, deploy through the web. You can just go to play.gno.land and actually, do this, right? You can actually deploy the whole application through the playground, which is really cool. And then this is kind of our ecosystem. We have some more things coming in, obviously, but there's Adina, which is the browser extension wallet. We have GNOScan, which is the blockchain scanner. We have the native kit. We have GNOSwap. We have JavaScript and TypeScript client. We have Territory, which are partners, and they have built a couple of applications on top of the GNO.land blockchain. We have Flipando, and obviously more of them. We actually have the native kit is really, really cool. For example, it's a way of doing GNO, but on as React Native, right? So as mobile applications. And then here's some opportunities here. What we want to do is we're actually inviting people to be the first, or you can read it as early, right, to build useful applications, dApps, and work also on the protocol level problems that we have. So you can actually make a very big impact on the future of GNO.land. Whoops. Sorry about that. Still good? Yeah? Okay. Awesome. And obviously, if you're looking to start a regional community or like a local community, do meetups for GNO, please reach out to us. This is a link tree. And it has a bunch of links, so if you do want to take a picture of this, and we can stay in touch. This is me. If you need my X or GitHub, it's just LEO and then triple H and then N. It's the same on GitHub. And I'll give you something else. Oh, are you taking a picture of that? Or, yeah, okay. Yeah, no problem. Yeah, I have a nice face. One thing that I really want to ask you guys is please take 2 minutes to just scan this and just give a little bit of feedback about today's presentation. So I'll just leave that up. But before we end the presentation, what do you guys think? What are thoughts? Do you guys like this? Was it too hard? Was it not too hard? Do you have any questions about it? Please, I'm listening. Okay. So everything goes crystal clear, right? Great. Awesome. Well, thank you so much for coming. We're about 30 minutes in, which is perfect. That's exactly what I wanted since it's almost 7 p.m. And thank you guys for coming, and I hope to catch you somewhere else.